So our quantifiers really, by themselves, if we're just attaching them to atomic formulas, they don't say, I mean, we can say a bunch of things. We can say everything is a horse, everything flies, something is tall. But they really get their power when we start looking at quantifiers attaching to logically complex statements or putting quantifiers inside of other operators. So in this video, we're going to talk about quantification and negation in particular. So what do we have here? Let's say we're talking about three different things, and that's all that we're concerned with. So when we use our words for every and some, it's just those ones that we're talking about. And let's suppose those are all, I don't know, let's say that they're just three different things, and we have names for them, A, B, and C. Which ones are they? We don't need to worry about. Just we've given them, there are three things, and we've given them each a name. Each one has a different name. And we might ask, what are they like? Well, let's suppose that we could say which predicate letters are true of each of them. So let's suppose that that one is G. Maybe G means is a giraffe, or is good, or whatever. Doesn't matter. G, our predicate letter, is true of so there are three things. There's A and B and C, and the predicate letter G is, in this way of saying it, or in this way the world is, true of B. Whatever property G talks about, B has that, but A and C do not. Or it could be instead that maybe all three of the things, A, B, and C, all have the property G. The predicate letter G is true of all three of them. That could be as well. So three things, each has a name, A or B or C, and then the predicate letter G in this way, as it's written here, is true of all three of them. Okay, so now let's ask whether various quantifier statements involving quantifiers and negations are true or false if we're using these statements to talk just about those three things. So let's ask first, is for all x, gx true? Well, there are three things, and so they all need to be G for that to be true. And if they are, then for all x, gx is true. And indeed, gx is true of A, gx is true of B, gx is true of C. That's all we're talking about. So when we say everything is true, or everything is G for all x, gx, that's true if those are the only three things we're talking about. What about not for all x, gx? Well, that always just has the opposite truth value of for all x, gx, and so it's going to be false. What that says is, it is not the case that everything is green, or it is not the case that everything is a giraffe. And that's not true in this scenario. Everything is a giraffe, everything is green, whatever, and so the negation of the universal is false. What about for all x, not gx? That says everything is a non-giraffe, or everything is a non-green thing. Everything isn't green. Each thing, G is false of that. Well, that's definitely not true because G is true of all of them. G isn't false of any of them, so that's also false. Okay, how about the existential ones? Some x, gx, definitely true. Is there a thing that's G? Yes, there are actually a lot of things, but at least one of them is G, so that comes out true. The negation of that, the opposite of it, comes out false because it's just the negation, so it just has the opposite truth value. What that says is nothing is green, and that's definitely not true. But in terms of just looking right here, the negation has the opposite truth value as the unnegated sentence. The unnegated sentence is true, so the negation is false. Good. How about the last one? Some x, not gx. That says something is such that not gx. Well, are any things not G? Is A not G? No. A is G. Is B an un-G? No. B is G. Is C a not G? No. So are there any things that make not gx true? No. So that last quantification is also false. Okay, good. What if we considered a slightly different scenario where it turns out that while A and B both have the property G, C does not have it. So maybe A and B are both giraffes, but C is a lion. Okay. Now what's going to happen? Well, let's look at for all x, gx. That says that everything is a giraffe, or everything is green, or whatever. Is that true? What do you think? It's not because of C. C makes for all x, gx false, right? C makes gx false, and for all x, gx to be true, gx has to be true of all of them, and it's not. Gx is not true of C, so for all x, gx is false. How about not for all x, gx? Well, that's just the opposite of for all x, gx, so it's true. And how about then, though, for all x, not gx? Is that true or false? What do we think? Well, that says everything is a certain way, namely not gx? Is everything not gx? Well, C is not gx, right? C lacks g, but A and B don't. Not gx, if we go to A, comes out false. Not gx, if we go to B, comes out false, because they both have the property g. So this time, for all x not gx is false. So we can see now that not for all x gx and for all x not gx do not say the same thing. They're different. The not for all x gx says, is everything a giraffe? No. That's true in the real world. For all x not gx says, everything is a non-giraffe. And that's not true either in the real world or in our little scenario, because there are giraffes, right? So those two do not say the same thing. Not for all x gx says less. It says, is absolutely everything a giraffe? No. And that's relatively easy to happen. But the second one, for all x not gx, that says a lot. That says everything is a non-giraffe. And that's harder to happen. And so in this scenario, it doesn't happen. Okay, what about the existentials? Some x, gx. At least one thing is g. Is that true? Yes, there are actually two things. A is g and B is g. So A makes gx true and B makes gx true. So there are multiple things that make gx true. So some x, gx, that's true. And so its opposite is false. What about the last thing? Something is not gx. What do we think about that? That says something, there's at least one thing out there in our little universe, not very big, don't have to look very far, but there's at least one thing out there that makes not gx true. Is there anything in our universe that makes not gx true? What do you think? Yes, C, right? C does not have the property g, it's not a giraffe, it's not green, whatever. So C makes gx false. So C makes not gx true. So is there at least one thing that makes not gx true? Yes, there is C. And so then we can also see that those two, the negation of the existential and the existential of the negation, do not say the same thing either. Let's look at another example. Well, if we take away g from A, then actually nothing's going to change. All these come out the same. As long as if at least one of the things, but not all of them, are g, then all those sentences don't tell us it's many of them, most of them, but two of them, they can't tell the difference. Our quantifiers are not very precise. They can do, are they all this way, are some but not all this way, or are none of them this way? But they can't tell the difference between is one of them this way or two of them this way. They can't tell. They can't count very precisely. They're just all, some but not all, or none, and that's all they can do. Well, what about if there are none? Then what happens? Well, for all x, gx is definitely false, because nothing makes gx true. Well, so its opposite is true. What about for all x not gx? Well, let's see. A lacks g, B lacks g, and C lacks g. So not gx comes out true no matter what. So for all x not gx is true. Good. What about some x gx? Does anything make gx true? A does not make gx true. B does not make gx true. C does not make gx true. So there's nothing in that universe that makes gx true. So some x gx comes out false. Therefore, its opposite comes out true. What about some x not gx? There are many things that make not gx true. A and B and C each lack g. Therefore, they each make gx false. Therefore, they each make not gx true. And so some x not gx is true. So let's write up now what each of these different sentences means. So here are all 6 of those sentences. 2 of them, the first one and the fourth, we already know. Everything is green and something is green. But the other 4 are new. So the second one, not for all x gx, that denies everything is g. It says it is not the case that everything is green. So is absolutely everything in the world green? No, at least one thing isn't. So that says the same thing actually as the very bottom one. It says something is not g. How about for all x not gx? That says everything is not green. All the things, wherever you look, not g, not a giraffe, not green, whatever. So all of them. So are there any g's at all? No, none at all. So that says a lot. It's a very strong statement. it's just as strong as for all x gx. They both say a lot. Whereas not for all x gx doesn't tell us that much. It just says, well, is absolutely everything G? No. How many things are non-G? I don't know, but there's at least one of them. Doesn't say a lot. Let's look at the fifth statement, not some x gx. So that's just the opposite of something is G, but the opposite of something is green is nothing is green. So that actually also says a lot. That says wherever you look, you're never going to find a green thing. And it's not because you're not good at looking, it's because there aren't any there to be found. Nothing whatsoever is green. And that's equivalent to for all x not gx. And then finally we have some x not gx. And that says something is not G. At least one thing is not green. How many things are not green? I don't know, except there's at least one of them. So that too does not say that much, but it says something. So let's just look for our last slide at which of these are equivalent to each other. We have two rows on which we have, and each row has two sentences, and the two sentences on each row are equivalent to each other. They always agree in truth value. So not for all x gx, that's equivalent to some x not gx. Some x not gx tells us something is not green. There's at least one thing that's not green. And not for all x gx says it's not the case that absolutely everything is green. So those agree. They both require for their truth that there be at least one thing that's non-green, and that's all they need. If there's one thing that's non-green, they're both true. If there are more things that are non-green, they're both true. When are they false? Only when absolutely everything is green. On the bottom, we have stronger statements that are also equivalent to each other. So everything is a the one on the left says everything is non-green. So everything, whatever color it is, not green. The one on the right says absolutely nothing is green. So those also agree. If everything is green, they're both false. If a few things are green, they're both false. But if nothing is green, that means also that everything is non-green, and they both agree. So those are both those two rows. They say the same thing. So our quantifiers and our negations can trade off, and there are different ways that we can say the same thing with a quantifier and a negation, with a different quantifier and a negation in a different place.